It's 2018, question 1. This is an accumulation problem. If you take a look at the highlights, we have two rates here. We have the rate at which people are entering a line and the rate at which people are exiting the line. Okay. They also give you a little fact here that at t equals 0, there's 20 people in line. Okay. So here we go. How many people enter the line? From 0 to 300. So we focus on r of t. That's the rate at which people enter the line. So if you want to get rid of the rate and just talk about the amount of people, you have to integrate this from 0 to 300. This is a quick plug and chug here. Be very careful in how you type out r of t, only because there's a lot that's going on there, okay? So you should get about 270, okay? Here's part B. So they tell you that from 0 to 300, there's always people in line. How many people are in line at t equals 300? So we want to find out how many people are in line at this particular time, okay? So what you guys want to do here is you have to consider, well, okay, do we have to consider how many people were waiting in line to begin with? We do, so we have to consider our start value. At the very beginning, there were 20 people there, okay? And then we want to find the total number of people that entered, which is pretty much what we did in part A, okay? We have to consider how much goes in, but we also have to consider what goes out. So we're going to have to subtract out the integral of 0.7 dt from 0 to 300. Okay? So you could combine those two integrals together if you'd like, but basically you're going to end up getting, I believe it's 80 once you do the math, okay? So now we know that there's going to be 80 people at t equals 300. We're going to need that for later, I believe, okay? So let's keep going. So part C, after 300 seconds, what is the first time that there are no people in line? Okay, so some things that you have to know. Let's go back to this piecewise function. So from 0 to 300, people are entering. But if you notice, right after 300, nobody is entering now. Okay, so there's no one else waiting in line. Okay, but people are still exiting. So what you have to consider is, well, how many people do we have at 300? Okay, at t equals 300, how many people do we have? We have exactly 80 people. Okay, right? Now, how fast are they exiting? Okay, so they're exiting at 0.7 people per second. Okay, so how do you find out how long it's going to take, right? So it's basically you just dividing these two here, okay? So you're going to divide to see how many seconds it's going to take. If you just take a look at the units, if you play with the units, people are going to cancel out and you're just going to be left with seconds, okay? If I'm looking at the scoring guidelines, it's looking like you'll get 114-ish. But remember, that's how long it takes for 80 people to exit, but there's 80 people at t equals 300. So it's 300 plus that 114-ish. I think it comes out to a total of 414.286 seconds there, okay? No need to put units because they don't ask for it, but just keep that in mind. Here's the last one, part D. For 0 to 300, at what time is the number of people a minimum? Okay, to the nearest whole number, find the number of people. Okay, so we need the time and the amount of people where the line is the minimum. Okay, so right away we have an extrema here. We're actually looking for a global or an absolute extrema since it's a closed interval. Let me make some space here. Okay, so since we have a closed interval here, we know that it could occur at the endpoints, okay, or it could occur at a critical number. So first, we want to make an equation for the number of people. Okay, the number of people is going to be 20 plus the integral of r. That's how you get the number of people that enter. Now the thing is, you're going to go from 0 to t. Okay? And actually what I'll do here is I'll change the variable so it looks a little bit better. R of x dx, okay? Actually, let me go back. R of x minus 0.7. I'm just combining the two integrals together just to make it look a little bit easier, okay? So that'll represent the number of people that you guys want at any particular time. So remember, absolute extremis could occur at the endpoints or at a critical number. Critical number is pretty much where the derivative is 0. So sidebar here, if you take the derivative of this equation here, the 20 goes away, and the derivative of an integral is pretty much just the integrand, r of t minus 0.7. What we're going to do there is we're going to set the whole thing equal to 0. Okay, so you can graph this here, probably y1 minus 0.7 as your y2, and then you calculate your zeros by going to second trace 2, and then you know the rest. But if you did it right, you should get, let me take a look here, about 33 and about 166. I'm not going to write the whole thing here, okay? But what you want to do is you want to plug it back into the original equation, okay? All of these here. So we know at time 0, there was exactly 20 people waiting in line. But basically, if you keep on going, you're going to get something like this. I'm just copying it down from the scoring guidelines. Remember, we're looking for two things. We're looking for the time and the number of people where it's a minimum. So it's going to happen right here. So at about 33 seconds or 33.013 seconds, there are about 4 people in line. And this will be your justification, okay?